Hello everyone, welcome back to my channel. Today we are going to discuss about lower bound and upper bounds. These are very important concepts with respect to binary search, and we are going to understand what is lower bound, what is upper bound. We are going to code lower bound and upper bound. Let's start with this. So here we are in our code editor. Let's start with the definition of lower bound and upper bound, and then I'll try to code it out, and then we'll eventually derive the generic template for our binary search. So what is a lower bound? So the problem statement is, again, you have been given an array, right? And this is a sorted array. 1, 2, 3, 5, 7, 9, 12. Now what lower bound says is lower bound is the first index where the element in the array is greater than or equal to the given target. So I'm also giving you a target. Let's say the target is 9. So what lower bound says is it is the index of the element in the given array which is greater than or equal to the target. So in this case, what will be the lower bound? The lower bound is going to be, let me also write the indices, that will be more helpful for you. So I have to return the index. Okay, cool. What will be the lower bound of 9? The lower bound of 9 is basically the first index where the element in the array is greater than or equal to the target, right? So if you see, we have the 9. So element is greater than or equal to, this is the first element which is greater than or equal to the given target. So this is the element which is equal to, so my index will be 5. Let's do one more. What will be the lower bound of 10? Now in this case, 10 is not present in this array, right? So what is the first element which is greater than or equal to 10? So 9 is lesser than 10. 12 is first element which is greater than or equal to 10. Now the answer will be 6. Okay, I hope this is clear. Let's talk about upper bound. Now upper bound is very similar, and so many people confuses it by the name. They think upper bound should be opposite to lower bound, but it is not true. Upper bound has a very minute difference with the lower bound. It says it is the index of the element in the given array which is greater than the target. So there is very minute difference. The difference is the lower bound, in lower bound the target is greater than or equal to the element of the array. Okay, but in case of upper bound, it says give me the index of the element which is strictly greater than the element, right? So if I'm talking about upper bound of 9 again, in this time it will be 6 because I want strictly greater. So I want something which is greater than 9. 9 is present, but I want something which is greater than 9. In that case, 12 is the element and the index is 6. Similarly, upper bound of 10 will again be 6. I hope this is clear to you guys. If this is clear, let's go ahead and try to code it out. Okay. So whatever we have learned from our previous video, we are gonna apply that, and we will try to modify it a little bit to basically serve our purpose. So let's start with this. So I will return the index. I will name this function as lower bound, and it will take an array of integers. Let me call it array, and it will have a target element. So as usual, we'll start with the defining the left and the right indices. Left is 0, right will be array dot size minus 1. This is what we have decided. We will always use left as 0 and right as array dot size minus 1. Now I'll write this while statement, while left is less than equal to right. Okay, and if this is true, so we remember we always have to use left is less than equal to right. Okay, let's define our mid here. Mid is equal to left plus right by 2. Okay, now we have mid here. So whatever the element I am at right now, it should be um, oh, I think I have written it in the wrong direction. So the element should be greater than equal to target, and the element where I am right now should be greater than target. Okay, now it does make sense. So whatever element I am at right now, I can say array of mid. This is the element I am at right now. If it is greater than or equal to the target, that means that it can be a potential answer to me, right? Because it falls under this category, right? It is greater than, it might be, it might be the answer or it might not be the answer. Let me have an example here. Let's say I have this array. Okay. Now, the target element is 2, right? And when I'm searching, I am at the mid, which is 5. Now, because I am at 5, this is a potential answer, right? 5 is greater than or equal to 2. Now, 5 can be my answer, but the real answer to this problem is 2. So what I can do is I can save this 5 as my answer for now. I will let this function to run. I will not stop it right now because I have got a potential answer, because I know it's a potential answer. It's not the real answer. So I will let it run, right? But what I can do is I can save this answer. Let's say if it happens to be my answer, it will get out of this loop. And because I'm saving this, this index as an answer somewhere, I can return that. So for this, let's have one thing. Let's have an answer variable which will be used for saving my potential answer at every point in time, right? So here, let's say because this condition is matching, I can say that okay, my answer will be mid, because this 5 is one of the potential answer. It can change. It might be possible that this is not the answer is lying on the left side, but for now I'll say, let's suppose this is the answer. And if this is the answer, I have saved the answer, right? And because I have saved the answer, what I can do is I can shift my right, I can shift my search space to the left side. Okay, so I'll do right equal to mid minus 1. So my right is now pointing to this 3. Okay, now you can argue like, okay, why are you doing right equal to mid minus 1? Why not right equal to mid? This is because I already have saved this as in my answer, right? I don't have to keep it. I can just lose it because I have it somewhere in my answer, like in a variable where I'm saving it. So I can lose it. I can afford to lose it. That's why I'm just losing it. Okay. Else if, or I don't think we should put else if, because there is only one condition left. And in that case, all I can do is left equal to mid plus 1. Okay. So let's suppose the target is 9 this time. Okay. I'm at 5. Now, because the target is greater than the element I am at right now, that means this cannot be my answer, right? So there is no point in putting left equal to mid. What I'll do is I'll put left equal to mid plus 1. The search space will shrink to this one now, 7, 9, 12. Okay, perfect. And what I need to do at the end is I need to return the answer. So let's dry run it once, shall we? So basically, let's say the target here is 2. What will happen is I will start from the mid element, which is 5, and I'll check if 5 is greater than equal to 2, and that's true. Now my answer will contain the index 0, 1, 2, 3, index of 5, which is 3. Okay, uh, and the right will become 2. Okay, so my search space has been, shrank to 1 to 3. Now again, I'll come and the mid is 2, right? I'll check if 2 is greater than equal to target 2, and that's true. Again, the answer will become mid, which is 1, right? The index of 2 is 1. And again, right will be equal to mid minus 1. So my right has become now 1. Now here, as I can see, left is less than equal to right, which is again true. I'll again come here. I'll check if array of mid is greater than equal to target. So array of mid is 1. Is it greater than equal to 2? No. I'll go to left. I'll go to the else part, and here left will be mid plus 1. So my left is at 1. It will become mid plus 1. It will come to 2. So my left will come to 2. The right is at 1, left is at 2. When I come to this condition next time, I'm checking 2 is less than equal to 1, which is false. And because it is false, it will not go inside this while loop again. And in my answer, I have 1 and I'll return 1. And that's how this lower bound will work. And let's try to run it with some example. So I'll have this vector of integer. I'll call it array, and let me put the same example here, and I will have target. Let's say the target is 2. Now all I need to do is call this lower bound and print it. Let me directly print it. Okay, I'm passing the array and I'm passing the target. Let's see what's the answer. Okay, I'm getting 1 as the answer, and that's correct. At index 1, I have my answer. Now let's try it for 7. 0, 1, 2, 3, 4. 4 should be the answer. Let's check. Yeah, 4 is my answer. Now let's try for 8. In that case, because we don't have any 8 here, the answer should be 9. Let's see. No, not sure why I got this error. Yeah. So I've got the index as 5. Let's see. 0, 1, 2, 3, 4, 5. And at the index 5, I have 9. And that shows that it is working and it's correct. Okay. Now, if you have to implement upper bound, what will you do? If you want to, just pause it for a second and think about it, you can do it. Otherwise, I'm just writing the upper bound here. So the condition says in lower bound, if my array of if my current element is greater than equal to target, then I will say, okay, this is my potential answer. But in case of upper bound, I have the strict condition that the whatever element I will choose as my answer, that should be strictly greater than the target. Now in this case, let's say 2 is, again, I'm getting 2 as my target. Now this condition will be satisfied. Let me delete it for now. And I'll come to the mid is 5, and I'll check whether 5 is greater than target. It is strictly greater than, then that's fine. I will say, okay, if it is strictly greater than, then answer will be 3 for now. And the right will become mid minus 1. Now my right is pointing to 3. And again, I will come to this while loop. The mid is 2 this time. Now I'll come to this particular check. It checks whether or not 2 is greater than 2. Now this condition fails. Because this fails, I'll come to this particular condition. It will say left equal to mid plus 1. Left is pointing to 0. Left will now point to index 1. So left is pointing to 2 now. So my search space now is 2 comma 3. Now again, again I will come to this while loop and it will work fine. So if you want to try and it more, you can do it by yourself. But this condition has to be changed only. The rest of the things is working fine. So let me also try to run this upper bound here and see if I'm getting the correct answer. Okay, upper bound. I'll have the array and I'll have the target as 2 this time. Okay, let me change the name of this function. This is upper bound. Okay, Let me try to run it and see for 2. So lower bound should give the exact index, which is 1, but the upper bound should give 2, which is the index of the element which is greater than 2. Yeah. So for the first one, I'm getting 1, which is correct, lower bound, and for the second one, I'm getting 2, which is also correct, the upper bound. Okay, so this video is getting a little bit longer. I still have to talk about the pattern we have discovered from solving lower bound and upper bound. And then I'll basically write down the generalized binary search template and all of these things in the next video.